is Olaf, and I am subbing for Mr. Meteor, who had some science-like things to attend to. But he wanted us to talk about possibilities for life in the universe. Now, the best candidate for life in the universe is a place called Europa. Europa is a moon of Jupiter. Does anyone know anything about this moon of Jupiter? No? Okay, that's fine. That's why I'm here. It was discovered in 1610 by Galileo. He was kind of a big deal in the science world. I don't know if you've heard of him. Whatever. Can anyone guess how far away it is? Anyone? Nope? Nobody at all? Okay. Well, it was located 6.3 million kilometers away from us, from Earth, right here, today.
How did he find something so very far away, you may ask? Well, Europa and 3 other moons of Jupiter are especially reflective, and even you could see what he saw now over 400 years ago with a regular pair of binoculars. Oh, do you have a question?
Isn't there like 12 moons around Jupiter? Why do we even care about this one?
I'm so glad you asked that because it's actually very interesting. And Jupiter has over 60 moons, by the way, not just 12. But we're wondering, why is Europa so special? How does it have the possibility of having liquid water? Well, let me show you. If we imagine that Europa is this ball, we can imagine that Jupiter is pulling on Europa with gravitational energy, and in turn is being stretched and pulled, which creates a thermal energy inside of Europa through movement, because kinetic energy can be converted into thermal energy, which would create the ability to have liquid water inside of it because it's so warm inside. Isn't that awesome?
So I understand why there's liquid water in Europa from the pulling of Jupiter to create the kinetic energy and thermal energy. But what I'm really wondering is what kind of water it is. Like, can we drink it?
Thank you for your wonderful question. Well, spacecraft were actually sent out that took measurements that indicate that there is a closed electrical circuit present, which leads us to believe that there is an abundance of salt water because it is such a good conductor of electricity. And now I can show you just how good of a conductor of electricity salt water is in the science lab. As you can see, we have a battery, simple wire, salt water, and an LED light. To show that salt water is a very good conductor, I will place both of the wires, which are connected to the battery, into the salt water, and it will light up our LED light. Ta-da! Okay. Finally, I will discuss Europa's structure. It's much like our own, with an iron core, and it also has a molten rocky mantle, which leads us to believe that it could have plate tectonics, much like Earth does, in that the ground would be able to move along the molten surface.
And here we have our ocean, which is about 60 kilometers deep, and then we have this thin layer of ice, which is about 15 kilometers thick.
And beneath all of this ice, dealing with the plate tectonics, there could be hydrothermal vents which have been shown to be quite important to the biology on our own planet. And I know that there is a person in this class that is very equipped to talk about hydrothermal vents. Cindy, would you care to talk about what you wrote in your paper last year that won a prize?
Sure. So the plate tectonics create little gaps in the surface. Not to scale, guys. Okay, so the core, which is under here, when it's getting pushed and pulled, will create the forces, and that creates the heat that escapes like a little tiny volcano into your ocean. And that creates your vent right there.
if you guys know this or not, but I was actually inspired to become a science teacher by a Mr. Bill Nye. Now, let's hear what our favorite science guy has to say about future missions to Europa.
20 years from 2014, that's possible. It would change the world for a price of a cup of coffee. And wait, there's more. It wouldn't be the work of a guy like Galileo. It would be the work of all of us. It would be the work of all of us taxpayers and citizens of the earth. Everybody would be involved. And if we were to find evidence of life, it would change the world. Change the world.
Well, class, that is it for today. I hope you learned a lot about Europa and why it is a very good candidate for life in the universe. Hello, class. Oh my gosh, I got to use practice. Did some astronomy type things to obtain
To attend to.
That's why I'm here. It was discovered. That's not what you wanted me to say. It was discovered in 19.
Probably not.
What should I write? 1916 or 1610. It was discovered in 16. Do I write Galileo Galilei? Has anybody heard of him? Yes. Come on. This is like sophomore science, right? What do you don't know Galileo?
How?
I don't know what to do. Let me show you. It creates tidal energy and heat, and it can take liquid water. So, the structure of Europa is beginning with an iron core, just like we have. Yeah. Dang it! Just like Earth does with plate tectonics. So, right here will be plate tectonics. Look at her. Hey, why doesn't Smarty Pants come up here and tell us about the hydrothermal vent? I want to do that. We should do that. Quite important for life.
Alright, we're good.
It's okay, right?
Yeah.
Okay. iPhone's really improved in the past couple of years. I cartwheeled in once.
That would be awesome. So why are hydrothermal?
Since it's so big, it's able to pull on Europa and create a sort of tidal energy as we do with the moon. This distance is 4 AU. Damn it, why did I even do this? That's so stupid.
That was good.
No. Okay, I can do it again. Okay. It is stretching and expanding and then contracting. One more time.
That was
makes it warm on the inside.
That was perfect though.
I know. Which creates a thermal energy inside of Europa, which when I saw you smile, damn it. And Jupiter creates so much, dude.
So what am I supposed to say at the end?